of Cyrus. What is the luminosity? What is the formula for luminosity? L is equal to sigma A T to the power 4. Is the formula that you did? What is the value for sigma?
5.67 into 10 to the power negative 8.
67 into 10 to the power of negative 8. A is equal to surface area 4 pi r square. R is radius. Radius is this divided by 2. Into 2 point. Okay, that means 1.11. 1.11 into 10 to the power of 36, right? Kilometer. So when you convert into meter, it becomes 9 meter. Now 4 pi r square. This square did you do?
Yes, miss.
Okay, this is sigma, then 4 pi, then r square, then temperature. Temperature is given in Kelvin and it has to be in Kelvin. T to the power 4, 12,000 to the power 4. Is this what you did?
Yes, miss. I got it, miss. It's 1.82. I got 1.78. Last time I got a very different answer because I didn't do the area separately. I put everything together. So I think I got mixed up.
So now did you get a similar answer?
Yes, I got 1.78 and the book answer is 1.82.
That is not a problem. That is because some of the small points you might have taken. Okay, that is not a problem. Okay, there's not a large difference. Any other question?
Miss, there is this 2B. In 2B, they said the wavelength was different. Then observe
2B.
the
Wait.
yeah.
2B. Okay, rest of you, we are doing this question now. Let me see. Okay, this one. Question number 2B. Okay. Question number this one. The sun's surface temperature has been measured as being 5,800. This is sun. Okay. T is 5,800 Kelvin. Calculate the peak wavelength of the solar system. What is the formula for peak wavelength? Lambda max is equal to Wein's constant. What is the Wein's constant? What is the Wein's
2.9 into 10 to the power negative 3.
2.9 into 10 to the power of negative 3 divided by
temperature.
Divided by temperature. So what is the temperature? 5,800. Is this what you did?
Yes, miss.
And you got the answer as what?
5.0 into 10 to the power negative 7.
0 into 10 to the power of negative 7. Okay. The peak wavelength from the sun is in fact measured at the ground level, being 417 nanometer. Now this is in what, meter or nanometer? Meter.
The answer is in meter.
Yeah. Why is the measured value different from your calculated value? The peak wavelength of the sun is in fact measured at the ground level, being 470 nanometer. Okay. Here you got how much? This is how many nanometer? Okay. 5 into 10 to the power of negative 7 into meter to nanometer is 10 to the power of 9, which gives you 5 into 500 nanometer. Okay. This is 500 nanometer, but they got it as 470 nanometer. 470 nanometer. Why is it so?
Miss, the atmospheric absorption, but I wanted to ask you, does this have anything to do with the Doppler effect?
Doppler effect, no. Why?
Okay.
Because the Doppler effect will be noticeable if one is from the sun and the other spectrum will be from a distant one, from another object which is going. Okay. If sun and the other one are still, are not moving, or if sun and this one are moving with the same speed so that this distance is maintained, you would not observe. You understand? If both of them are either not moving or moving with a constant speed, then this distance will not change, right? So in that case, the spectrum from this and spectrum from this would be same. But if this is not so, if this is moving slowly and this is moving very fast, then only you see Doppler effect. Doppler effect is seen only if there is a relative motion. Okay? Relative motion. That means one is moving faster, other is moving slower. When if you look from here, you will see that this is moving faster. Or when you look from here, you will see that this is moving slower. That effect only if there, then only Doppler effect will come. This is due to the atmospheric absorption. Yes, this is 500 nanometer, 500 nanometer, and this is 470 nanometer. Which is longer? This is longer. Okay, so that means when some of these longer ones are absorbed, what is left is the shorter one. Shorter wavelengths are less absorbed. Longer wavelengths are more absorbed. That is why you feel the sun as blue. Why do you, oh, sorry, not sun. Why do you see see blue sky? Why is the sky blue? Because sun sends all the radiation, but after passing through many layers of the atmosphere, the longer wavelengths are absorbed. Vibgyor of these Vibgyor, the longer wavelengths are absorbed. So what is left is this higher wavelength, violet, indigo, blue. A collection of this, right, is seen to you as blue color. That is why the sky is appearing blue. All right.
Yes, miss.
Yes. Okay. So now last class did we learn about dark matter and dark energy and the future of the universe? Did we learn?
No, miss.
Okay. Now we have learned about Doppler effect, and we saw this Hubble's law. Did we learn? I think yes. Hubble's law, and to find the age of the universe, we did, right? What does Hubble's law say? Very important question. Hubble's law says that the receding velocity and the distance to the distant star are directly proportional. What does that mean? If this is our Earth, if this is our Earth, you have got one star 1 here, star 2 here. Okay, so this star 1 is closer to you. So that means assume that this is star 1. This star 1 is closer to you because distance is less. Then that means it's receding velocity. So this is moving away, but moving away slowly, but it is moving away. It is moving away. That is why you see a change in the wavelength. But it is moving slowly. How can you say that it is moving slowly? Its red shift is less. If the red shift is less, that means it is moving slowly. If the red shift is more, that means it is moving faster. Now, compared to this, what can you say about this one? This is also moving away, but much faster. Why? Because its Z value. What is Z? Doppler shift. How will you calculate the Doppler shift? Change in wavelength by original wavelength, or change in frequency by original frequency. Okay. So if the redshift is more, that means it is traveling faster. So this will have a bigger Z value. This will have a smaller Z value, but both of them will have a positive Z value, showing that they are moving away. So since its Z value is larger, it is moving away from us much more faster than this one. That is shown over here. V is equal to V and D are directly proportional. This is Hubble's law. Okay, very important. And what is the other significance? A graph of this, sorry, a gradient of this is equal to V by D. Now, what is this one? This gradient is called Hubble's constant. Okay, and if T naught is the age of our universe, T naught is equal to, that means the time is equal to distance by speed, D by V. Okay, our age of the earth, T naught is equal to distance divided by speed. Now this is V by D. So V by D is HO. This is D by V. That means 1 by HO. This is the significance. And this Hubble's law, that means this gradient 1 by HO, that means 1 by gradient of Hubble's graph. Okay, so this is the significance of this Hubble's law. Hubble's law says that receding speed, that means the speed with which the star is moving away from you, is directly proportional to this. In simple terms, closer stars move away slowly, farther away stars move away from us faster. The faster you go, you will see that they are accelerating. These stars are going away with accelerating speed. Okay, so that is the significance of Hubble's law. And I gave you question on Hubble's law as well. Now what we have to do is dark matter, dark energy, and the future of universe. Dark matter. You know what is the normal matter? What is the normal matter? How do you see the normal matter? For example, how do you see this pen? This pen is made up of normal matter. How do you know that there is this normal matter? Because it's reflect light. Okay, it reflects visible light. That is why you can see. If that means when the rays fall on this and the reflected ray fall in our eye, only we see this. This is the normal matter. Normal matter we see because it reflects light to our eye. Now, what if there is something that does not reflect light to your eye? That will look to you as dark. That will not show you any evidence of its presence. That is called dark matter. How did scientists ever come to know the concept of dark matter? When scientists were trying to find the density of the universe. Okay, why did they find the density of universe? See, look here. If this is the whole universe, you know that there are two forces acting. One, it is gravity pulling towards the center. Gravity pulling towards center, which is trying to bring all of them closer. Different galaxies here, all of them have mass, therefore they have gravity, and it is the gravitational force that is bringing all the different parts of the universe, different galaxies into one center. But there is the outward force. Okay, the outward force of expansion. Now, from the Hubble's law, we see that the galaxies are going further away from us. Okay, so scientists began to think, will ever this universe come back to the original size, or will the universe go on expanding and then finally what will happen? Okay, so they thought that they wanted to find out, is there any chance of this expanded universe coming to a small point, which is called a big crunch. So that means we need a bigger gravitational force to attract them. If you want bigger gravitational force, then the mass must be bigger. Okay, only if the mass is more, gravity can be more. More precisely, density of the universe must be large enough. Okay, this density should be above a certain value called critical density. If the density is bigger, then you can say that once this expansion will decrease, then gravity will take over and will come back to original small size. So scientists were studying about this. Okay, and we know that galaxies emit light. We can measure its brightness, etc., from the and the distance to this from the actual luminosity, and we can estimate the mass of the stars. How? Because luminosity has a formula, sigma is sigma a t to the power 4. From the area, okay, the temperature can be found, luminosity can be found. So from that you can find the area, surface area of the star. If the surface area then you can find surface area is equal to 4 pi r square. So you will get an idea about the radius of that. If you know this radius, you can find the volume because it is simply 4 by 3 pi r cube. You can find the radius. So from the volume. So if you know the density, if you know the approximate mass and volume, you can figure out the density of the universe. Okay, and also we know that the galaxies rotate, and this means that all stars should have a centripetal force. Okay, so they also have found that these galaxies are rotating around a certain axis, and if they want to rotate, there must be centripetal force. Centripetal force is mv squared by r. All right. So when what is the speed? This is the rotational speed. When the astronomers measure the rotational speed of stars in the galaxies, they find for a galaxy to have certain speed, there must be certain mass. We have found out the speed of the galaxy. Okay, the speed of the galaxy, and we know how much centripetal force is needed for a galaxy to rotate. So for this centripetal force with this much speed, the mass that they calculated was not sufficient. There came the problem. Okay, then they estimated the amount of centripetal force needed for this velocity, but the mass which was needed to compensate or to provide the centripetal force was too less. Okay, the mass was less. Then scientists assumed that there is something called dark matter. Why dark matter? Because it doesn't reflect light. Okay, it doesn't reflect light. So that is why. So from this discrepancy in the mass only, scientists came to know that there is something called dark matter. Otherwise, the mass of the universe which they have calculated is not sufficient to provide this much centripetal force. Okay, so they call it dark matter because it doesn't reflect any light. If so, there is another thing called dark energy. Okay. What is this dark energy? So from the Hubble's law, we have learned that the universe is expanding and the rate of expansion is increasing. universe is getting larger at a faster and faster rate. And we don't know what is causing this expansion. Okay, we don't know what is causing. So that there must be some energy pushing it outwards. All our calculation does not match with that. So they assume that there is something called dark energy, and it is the dark energy which is pushing the universe away. Understand? So many of these things are assumption only. One of the reasons is that it is too far away from us, and the amount of information which we can collect is limited. So most of the things are done by all these conclusions are drawn as assumptions only. So scientists could not find out why the earth is why the universe is accelerating at a faster rate. So they made themselves satisfactory by explaining that there is some unknown energy called dark energy, and it is the dark energy which is pushing the universe out, and that is much bigger than the gravity. That is why gravity is not able to make the universe stable. And that if this is the whole universe matter, the ordinary matter is less than 5. This is only ordinary matter. This is only 4.9%. Then they said that this much, around 1/3 is dark matter. This is the ordinary matter. This is the dark matter. And the rest all dark energy. Okay, is that understood?
Yes, miss.
Okay, now what is the future of the universe? Okay, so then they have found that, or they have assumed that there is something pushing outwards, which is due to dark energy. If the universe keep on expanding, where will they end? Okay, if the universe keep on expanding, where will it end? There are 3 possible suggestions about the future of the universe. One is that they suggest that after some time, the universe will stop expanding. Okay, the universe will stop expanding, and it will not later then compress also. It will stop expanding, and that theory, okay, or that universe which is going to stop expanding and maintain a constant size is called flat universe. See, flat universe. It will go away after a certain time, the distance. Okay, so this graph is for flat universe. That means it says that it suggests that every galaxy will expand on their own, but at some time the expansion will stop. So such a state is called flat universe. Expansion stops. Okay, why? All right. So if it gets over, I will send you another link. Okay. Okay. So that means this flat universe means if this is the initial size of the universe, it got bigger and it got bigger. See, it was small, bigger, and assume that at this stage is this one. Then what happens? It remains flat. That means this size of this remains constant. So this is a flat universe. Some scientists believe that the universe will go on expanding. The universe will go on expanding. And this type of universe is called open universe. And very few people still believe that there will be a stage where this increases and then it will stop. Finally, it also will come to rest. So this type of universe is called for closed universe. Okay, so these are the three predictions about the future of the universe. Is that okay? Now all the rest you can read from the textbook. Okay, you can read from the textbook. Just go through this and hello. Theories about the future of the universe. Flat universe means finally it will come to stop. Closed universe means this was the original size, it increases, and then it will shrink. Okay, so for this scientists say that at one stage gravity will take over, and the open universe means it will keep expanding forever. It will keep expanding forever with no stop. So these are the three possible stages in the future of the universe. Okay, so with that we finish astrophysics. And now we have got one more chapter left, which is oscillations, which is very little only. Then we can start doing past paper work. Just go through and tell me if you still have any doubt on astronomy. Start with oscillation.
Yes, miss.
Okay. Now this will get over quickly. Now I will send you another link. Otherwise, this will stop. Okay. I will say what is oscillation and what are the things you know about oscillation. Huh? What is an oscillation? Any periodic motion is called an oscillation. What do you mean by periodic motion? Periodic motion is something which gets repeated regularly. Okay, which gets repeated. For example, assume that this is a line. This is a point A, and this is a point A, B, C, C, okay, D. If an object, if a person goes there, comes back, goes there, comes back, goes there, comes back, this is a periodic motion, right? If a person goes there, like this, and like this is one motion. If this gets repeated, that is another periodic motion. Okay, any periodic motion, that means something which gets repeated regularly, is called a oscillation. Now, what is simple harmonic oscillation or simple harmonic motion? All oscillations are not simple harmonic. Okay, so about oscillation, you have learned about waves. Wave is an example of oscillation. Why? Because this is one wave. If the time taken for this one wave is t, then the time taken for the next wave also will be t. In the same time, this motion keeps repeating. Okay, so this wave motion is also oscillation. Another example, when you are in a swing, when you are moving in a swing, if this is your mean position, you move to one side, returns to the mean position, goes to the other side, returns, and this motion keeps repeating. This is also oscillation. All right, now what is simple harmonic oscillation? Simple harmonic oscillation or simple harmonic motion is an oscillation if it satisfies two conditions. Okay, any oscillation is a simple harmonic oscillation if, okay, so simple harmonic motion is a periodic motion, that means repeated motion, periodic motion in which two things are satisfied. Okay, what are the two things? If those two things are satisfied, then only you can call simple harmonic. What are the two things? Let's learn. You think about a pendulum. Okay, can you see? Yes. You think about a pendulum. This is a pendulum. Okay, it is suspended. This is the mean position. What do you mean by mean position? The position in which, okay, the position about which the particle moves, or the position where the particle has, yes. For example, if this is a rope, when the wave was not there, all these particles were here. So mean position is the position of the particle when there is no movement or when there is no wave. So if there is no wave, this string and this mass will be in this position. So this is called the mean position. Now, when you lift it, okay, when you give some force, this will move there. Now this position is called extreme position. Extreme position. Okay. Now look here. Once you have lifted to this, what will happen to this? Will it stay there? Will it go further when you release your hand? Or will it go to the right? Or will it go to the left? After this, what will happen? Hello, are you there? Can you hear me? Then tell me. You have pulled it up and then you left your hand. What will happen to this?
It will go to the mean position and then again to the left.
Wait. It will go from here, it will go to the left, right? For it to come to the left, there must be a force, because at this moment there was zero velocity. It stopped moving. Then if it wants to go, there must be a force. And you know that it will come in this direction. It will come towards the mean position. That means there must be a force in this one. Where does that force come from? And is the force in this direction? You have to find out. Where does the force come from? Then you think about the forces acting on it. You think about the forces acting on it now. When this bob is over here, what are the forces acting on this on the pendulum? One is the gravity and the other is the tension. All right. If this angle is theta, okay, this angle also would be theta, right? This angle also would be theta. Now this force is not just G, the weight mg. This force will be its weight. So this force can be resolved, if this is theta, can be resolved one along this as mg. If this is theta, what component is this? Tell me. This I want to resolve one like this and one perpendicular. So what will be this component? Cos or sine? Measure cos. Why? Because this is theta, so the side touching theta will always be cos. And this one will be mg sine theta. Is this a force? Yes, it is a force. And it is this force which is pulling it towards the mean position. Fine. So which force is trying to pull it? Mg sine theta. That means the perpendicular component of the weight. Perpendicular component of weight is the force which is bringing it back to this position. All right. Now it came over here and it went to this side. Okay. Here what will happen? Will it go? Will it continue moving to the left or to the right? To the right. Why to the right? Here it moved to the left. Then why here? Why is not going to the left? Why to the right? You resolve the force again. This is mg. If this is theta, this will be mg cos theta. Mg cos theta will balance the tension. Mg cos theta will be equal to tension, and the other perpendicular component will be this one. This is mg sine theta again. So what is the direction of this mg sine theta? To the mean position. This is what you have to understand. This is the force. Whether it is to the right or to the left, the force is always towards
the mean position.
What is it? Mean position. So this is one of the conditions. So if the force, and this force is a restoring force, if this force is always directed to the mean position, then the motion of the pendulum can be called simple harmonic. Simple harmonic. Okay, so that's the first condition. The restoring force should be directed to mean position. If force is to the mean position, what about the acceleration? What is acceleration? Acceleration is equal to force by mass. Mass has no direction. If force is to the mean position, acceleration also will be to the mean position. So both force and acceleration should be directed to the mean position. Second condition. Okay, second condition. The acceleration. Okay, the acceleration all right, one more thing. Here, this was the mean position. you moved it to the right, the force is to the left, right? That means you moved it to the right means the displacement x was to the right and the force is to the left in this case. In this case, what happened? The displacement is always measured from the mean position. You moved it to the left. That means the displacement was to the left, but the force is in which way? Force is to the right. This is the second condition. What is that? The force and hence the acceleration must be opposite direction of displacement. Okay, it must be directed to the mean position and the force or acceleration must be directly proportional. Okay, directly proportional means what? If you move it small distance, then the force will be small. If you move it large distance, then the force will be large. Why? The theta will be smaller. You understand? How is the sine curve? This is a sine, right? The sine curve is like this. Sine 0, 0. Sine 45 is something like this. This is sine 91. So as theta increases, sine theta, as theta increases, sine theta increases. That means if it is over here, theta is more, the restoring force is more. Okay, the restoring force is mg sine theta. As theta increases, okay, you can write like this. The force is mg sine theta. As the displacement x, okay, remember x is the displacement, increases, theta increases, therefore sine theta also increases. What does that mean? If sine theta increases, what happens to force? Force also will increase. This is the second one. What is the, so how can we write the second one? The restoring force is proportional to the displacement. Understand? The smaller you pull, small is the force. Larger you pull, larger is the force. The restoring force is directly proportional to displacement and the force must be opposite to the displacement. Okay? The force must be directed to mean position. That means opposite to displacement. If the displacement is this way, force is in the opposite direction. Okay, so there are two things. One, the force and acceleration opposite in direction to displacement and always towards the mean position. Second one, force is directly proportional to displacement. So combining these two, we can write the force is directly proportional to negative of displacement, or acceleration is directly proportional to negative of displacement, right? If this is satisfied, then only you can say any motion obeys simple harmonic. Any motion is simple harmonic. Okay, let me summarize again. A motion is simple harmonic or an oscillation is simple harmonic if the restoring force acting on the object is always towards the mean position, okay, and opposite in direction to displacement and proportional to displacement. This is how you define simple harmonic motion. Is that understood? Understood, or you want to write it down now? Respond. Are you there, Sanjida? Sanjida, are you there?
Yes, miss.
Shall I continue?
Yes, miss, sure.
Okay. So now what we are going to do is we are going to we are going to find the equations of displacement, equation of velocity, and equation of acceleration. Okay, displacement time graph, velocity time graph, acceleration time graph. That is what we are going to do for a simple harmonic motion. The equations for simple harmonic motion. Okay. First of all, display number one, equation for displacement. Displacement could be in the x direction or in the y direction. Okay, could be in the x direction or in the y direction. Before that, let's have a quick revision of some circular motion. Okay, see, look here. This is a simple harmonic motion. Now we know this is the mean position. All right. This motion can be compared, or this is a simple harmonic motion, right? Now this can be very, very well connected to a circular motion. How? If you put this part under this, okay? So this is the first part. If the second part is put under, it becomes a circular motion, right? So the concepts of circular motion can be applied in simple harmonic motion as well. What are the concepts are we going to take? Number one, if you look here, let this be a particle. This is in the x direction. This is the y direction. Consider a particle over here. This particle is moving in this direction, and in certain time, assume that it has made an angle theta in a time t. All right. How do you define theta? Theta is equal to, if the arc length is s, this is r, theta is equal to s by r. Okay. Also, we learned angular velocity omega is equal to what? Angular velocity omega is equal to theta by t. So from this, you can find omega is equal to theta is equal to omega t. We want this in this equation. Did you understand how we got this one? The angle is equal to angular velocity into time. This is same as distance is equal to speed into time. This is angular displacement, angular velocity, which is the speed, time. All right. And we also know that this omega is equal to 2 pi by time period, or omega is equal to 2 pi f. All these things we did earlier. I hope you remember in unit 5, sorry, unit 4. Remember? Huh? Okay. All these are circular motion. We need some of these concepts over here. Now, how do we get an equation? For getting an equation, see, look here. This is an object moving in this direction with an angular velocity omega. Okay. Now, when this is a particle, this is the center, this is the particle. When the particle moves after some time, say the particle is over here. When the particle is over there, see, okay, the particle actually moved along the circumference to this. When the particle is this is its maximum distance, right? So this can be called as the amplitude. Okay, maximum it can go. Now this we can draw a perpendicular down here, right? When the particle is over here, we can draw a perpendicular to the x-axis. Okay, that means this perpendicular moves from here to this to this. When the particle is here, the perpendicular to the x-axis is here. When the particle is here, its perpendicular is here. When the particle comes to this, its perpendicular is this. When the particle comes here, its perpendicular is this. When the particle comes here, this is the perpendicular. When the particle is here, this is the perpendicular. When the particle returns, this is the perpendicular. What does that mean? When the particle actually moves in a circular path, the foot of the perpendicular, these points are the foot of the, okay, the foots of the perpendicular was moving which way? The perpendicular was here, it went to the mean position, went to the other side, again returned, again went there. Okay, actually it made this movement. Here this we took it as x-axis. So we can make an equation for the displacement. So this is the displacement. So this is the basic concept. When a particle or an object moves along the circumference of a circle, its foot of the perpendicular to the x-axis makes simple harmonic motion. Is this point clear? The particle is actually moving in this path, but as the particle moves, whether it is in the up or down, its foot of the perpendicular is always here. It was here, 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 then came back to this one. Okay, so we are going to learn about the motion of the foot of the perpendicular. Okay, now, and x is the displacement. Okay, let this be x. X is the displacement. Maximum displacement is this, right? Because this is shorter, this is shorter, this is longer. Right? This is again shorter, this is again shorter, this is 0. So whether the particle is up or down, the perpendicular is always along the x-axis. Right? Now, second concept. Let's make this. This is the initial position. At any time, the particle is over here. So we know that this and this is the maximum displacement. So this is amplitude. Then this length is also, this is the radius, this is also the radius, this is the amplitude, maximum displacement. Now where is the foot of the perpendicular? This is the foot of the perpendicular. And what is x? This is x. From this to this one, this is x. If this angle is theta, this whole length is, say, amplitude. How much is this? X. Or what is cos theta? Cos theta. What is cos theta? What is cos theta? Cos theta is adjacent by hypotenuse. Adjacent is x. Hypotenuse is this, which is the radius. This radius is same as this one, maximum displacement. So A. Cos theta is equal to x by A. Therefore, x is equal to A cos theta. This is the derivation of the displacement. Let me write again equations for displacement. Okay. So from this, cos theta is equal to x by A. Therefore, x, which is the displacement, is equal to A cos theta. And what is theta? Omega t. Therefore, x is equal to A cos omega t. This is the equation for extreme position. Sorry, this is the equation for x displacement. Also, now the same motion if you study, okay, this is the particle is now here. instead of taking, are you following? Instead of taking the perpendicular on the x-axis, what if you take the foot of the perpendicular to the y-axis, this axis? Earlier we took it to the x and we got a distance for an equation for x. Similarly, we could get an equation for y as well. Let me draw this figure a bit more bigger. This is the initial position. This is the final position. After a time t, this is a b. This angle is theta. Angular velocity is omega. Now what are we doing? Instead of taking the perpendicular on the x-axis, we are taking the foot of the perpendicular to the y-axis. This is also making simple harmonic motion. Okay, why? Because when the particle is here, its foot of the perpendicular is here. When the particle is here, its foot of the perpendicular is here. When the particle is here, here. When the particle is here, 0. When the particle comes here, foot of the perpendicular is here. Here, foot of the perpendicular is here. Here, foot of the perpendicular here. Here, foot of the perpendicular here. Like that means if the particle goes like this, it foot of the perpendicular to the y-axis. Now this is y-axis. Also makes simple harmonic motion. So this also you can think it as the so now here this is the displacement. Let's take it as y. This is a. Now this angle. Okay. Let this angle. Okay. This angle is theta. This angle is theta. Now here what is theta? What is sine theta? Sine theta. This is a second equation. Sine theta is what? Sine theta is equal to, yeah, this is cos theta. This is sine theta, right? Yes. Sine theta. Now this one is same as this. This length is same as this. This is y. So sine theta is equal to y by amplitude. Therefore, y is equal to displacement along the y direction is equal to a sine theta, which is y is equal to a sine omega t. We got two equations, one on the x-axis, other on the y-axis. Now you should know the difference between them. We can, for the next equations, any one of which you can start, either y or x, doesn't matter. But you should know when are we taking x, or if the equation is x, what is the starting position. Here, okay, in this case, the particle was here. This is for x. Now this is the main position. This is the extreme position. So we use this if the starting point is extreme. Extreme. Is this clear? We use this equation if the starting point is extreme. Now, when do we use this? We use this when it is over here. Okay, because initially when the particle is here, the foot of the perpendicular is here. When the particle is here, it is like this. When the particle is here, it is like this. So this now this position is mean position. This equation we use when the starting point is at mean position. If the starting point is at the mean position, that means we are using y displacement. If the starting point is extreme, we are using x displacement. Is this much clear? In your book, they are using a cos theta for deriving the rest. But I am going to use a sin theta so that you will know both are same. Both of them are same for this one. The only difference is that where did we start calculating from? If we start calculating from the extreme, then the equation would be on the x-axis, on the is for the x-axis. If we start from the mean position, then the equation is for y-axis. That's the only difference. Okay, and this is a sine graph. How is the sine graph? So equations of motion would be like this. Y over here a long time. In the beginning, theta is 0. Theta is 0. Sine 0, 0. Then when theta increases, sine also increases. Then after 90, decreases. Then it goes in the opposite direction. All right. So this is a sine curve, and this is the equation for y-axis. How will the curve for x be? If you want to draw the curve for x, first cos 0. Cos 0 is +1. So it starts from extreme. See, it starts from extreme. Then it goes here, down here, and come back. So the graph for this would be like this. Please get the difference. Whatever graph you get in the exam, you should know it is for same thing, and we got them by taking the foot of the perpendicular. That's it. Is this much okay? You want to take down some notes so that you won't forget some rough note. Later you can write in detail. Equal to 0 at the extreme, then cos function. That's all. That's all. If we start timing from here, then what you get is cos, because that time you have got maximum amplitude. Cos has maximum amplitude. If you start from here, that time it has 0 amplitude. That is why sine 0 is 0. Hello, Mana. Finished? Rate of change of displacement is velocity. Rate of change of displacement. Velocity is the rate of change of displacement. How do you put it mathematically? dy by dt. All right, dy by dt. This is one way of getting understanding. So let us continue. You know about differentiation. Sanjita learned differentiation, right? Marshall? Okay, let's put it d by dt of y. What was y? Y was a sine omega t. Okay, help me differentiating. A is a constant, amplitude is a constant, take it out. A into d by dt of sine omega t. What is this? A into, what is the differentiation of sine omega t? Sine theta. D by dt of sine theta is cos theta. So cos omega t. Now d by dt of omega t. Okay. So these are the different steps in continuous differentiation. First you take the constant out. Then you do differentiation of this. Differentiation of sine theta is cos theta. Okay. So sine omega t, you did cos omega t. Now this also needs to be differentiated because it has a constant and a variable. Okay, all the things that has a variable needs to be differentiated. Okay, so that means d by dt of omega t. Now what you get? This is equal to a cos omega t into, what is d by dt of omega t? Constant out. Okay, that means omega, which means a omega cos omega t. This is the velocity equation. So v is equal to a omega cos omega t. If you have taken y as the displacement, had you taken x as the displacement, what will you get? Dx by dt. Remember? Okay. Now what is this? D by dt of the other equation. What was that? What was x? A cos omega t. All right. A cos omega t. Now what is the differentiation of this? As I do in the same step you do, a, now d by dt of cos omega t is minus sine omega t. Now d by dt of omega t is omega. Okay, so what will you finally get? Negative of a and omega constant, a omega sine omega t. So had you taken x, then this is the answer. If you have taken y, then this is the answer. Now let's see how is this from this one. This rate of change of means actually what? Using this one, it is the reflection of the gradient. Okay, so velocity time graph is a gradient. There are two ways to get it. Number one, okay, number one is using the mathematical way, which is differentiating the earlier answer, right? Second way is from the graph. You know that velocity, okay, velocity time graph is showing how the gradient of displacement time graph changes. Okay, so in this one, what you have to do? Use this and just show how is the gradient change. That's all. So let's put that over here and let's see whether that is matching with this equation. Okay. This is VT graph. Are you following what I'm saying? This is all a revision of unit 1. Unit 1, the first thing, motion graphs. Now look here. Do you have a bigger gradient in the beginning or here? Where do you have? Beginning or here? Where do you have a bigger gradient? Look at this one. Fareen. Hello, are you there? Sanjida.
Yes, miss.
Where do you have a bigger gradient? In this one, you have to show how the gradient is changing. Now, do you have a maximum gradient here? Slope. Gradient means slope. Or do you have a maximum gradient here?
No, at the beginning.
In the beginning. In the beginning, you have the maximum gradient. Then gradient decreases, decreases, decreases to 0. Just show that over here. Maximum gradient means maximum velocity. Then in 1 quarter, this is 90 degree, 1 quarter after 90 degree. After 90 degree, it becomes 0. See, the gradient becomes 0. Now what happens? It's a negative gradient. Okay, here it was a positive gradient. So this was in the positive part. Now the gradient is decreasing. So not gradient is decreasing. It has a negative gradient because this is y2. Y1 is bigger. Y2 minus y1 is negative value. So that means it must come in the negative half cycle. See, look here. This is gradient 0, gradient 0, gradient maximum. That's why gradient 0, gradient maximum, but in the opposite direction. Now again, in this part, you have in the next quarter, you have a maximum gradient decreasing back to 0. Here gradient is 0. Okay, still negative gradient. That's why still in the negative part, gradient decreases to 0. Right? Then what happens? This is 0 gradient. This is maximum gradient. So it goes to maximum gradient. Is this the graph for this one? This is a cost graph. This is a cost graph. Marshall?
Yes, yes, yes.
This is a cost graph. And this one is maximum. So this velocity maximum, when will you get velocity maximum? Okay, from this one or from that. Velocity is maximum when omega t is 1. Okay, when in this one, cos omega t is 1. Okay, we are talking about this. When cos omega t is equal to 1. For cos omega t should to be 1, what should be omega t? 0. Okay, that means only cos 0, because cos 0 is 1. Is this 0? Yes. At 0, you got maximum. When the angle is 0, you got maximum. Right? So cos omega t is 1. When so then you will get V max. So how much is a V max? V max is equal to A omega. You understood? Yeah, okay. So now, so this value, how much is this value? This value is maximum displacement omega. Similarly, this value is minus A omega. All right, okay. So similarly, you can try at home, taking this graph for the x, taking the cos graph, and you see whether you are getting a sine graph while you project the gradient. Okay, this you try it on your own. I'm only saying for y-axis because this is given in your textbook. You can refer. You try it on your. If this is a pendulum, when theta is equal to 0, what is theta? This is theta. Okay, when theta is equal to 0 means where? Okay, this is when theta is equal to 0. So where is this? At mean position. So here theta is equal to 0. V max is over here. You understood? When does it have maximum velocity? When theta is equal to 0. That means when the particle is at the mean position, it has maximum velocity. Now let's find out where is V minimum, minimum velocity. Now look at this equation. V minimum is equal to 0, where when cos omega t is equal to 0. When is cos omega t 0? At 90 degree. This is pi by 2, right? 90 degree. That means omega t is 90 degree. When is omega t 90? This is 90. Theta 90. That means extreme position. That means this is the extreme position. Here, theta is equal to 90. Okay, maximum. The maximum one we are taking. We are talking, not this position. Maximum it can go up to this. Okay. So this is V minimum and it is 0. All right. At the extreme position, it has 0 velocity. So that is what all these points are important. You will have the maximum velocity is a omega. For this also you will get the same thing. Minimum velocity is 0, where at the extreme. So this is very easily understood. When a pendulum makes simple harmonic motion, here, okay, first you pull it to this, and its speed becomes 0. Then the speed increases to maximum, decreases to 0, speed increases to maximum. So here you have got V max, and how much is that? A omega. Do you want to note it down or later? If you want to write some simple notes to make you understand, you can do that. Later, you have to really explain it well and right. Very important one. All right. Okay, so please practice this one. Now, third graph is what? Acceleration time graph. Let's do it by both ways. Number one, acceleration is equal to rate of change of velocity dv by dt. What does this mean? Rate of change of velocity. Let's use calculus to do that first. A is equal to d by, oh, acceleration and amplitude, you're getting confused. Then let us make the amplitude capital A. Okay. Let's put amplitude capital A. Let's make amplitude capital A. So A omega. Let's, okay, you make all A's amplitude bigger. Okay. And here also amplitude bigger. Otherwise you will get confused with acceleration. All right. So, otherwise, what is dv? What is omega? Hello? And now is it okay? Okay, I'll explain again. Acceleration time graph. This is equal to rate of change of velocity. So dv by dt. And what is v? A omega cos omega t. Differentiation. How do you do this? First of all, you take the constant out. A and omega both are constant. A omega. Now d by dt of cos omega t is what? Minus sine omega t into d by dt of omega t, omega. All right. So what do you finally get? A is equal to 2 omega, and there's a minus, and a omega square, 2 omegas sine omega t. So this is the equation for acceleration. Okay, and let's write acceleration maximum. When is acceleration maximum? When sine omega t is 1. Okay, when sine omega t is 1. Sine omega t is 1 means what is the magnitude of maximum? A omega square. Okay, and when is sine omega t 1? When this is 90. Okay, now sine 0. Yes, so for this one, okay, so this is a sine function again. You will get a sine function, and it is 1 at 90 degree. That 90 degree means at the extreme. Okay. Yes, this is when sine omega t, when omega t is equal to 90 degree. Right. 90 degree means at the extreme. Right. So for example, if we draw here, this is the main position. So acceleration is A max is at the extreme. And how much is this A max? Omega square A. Now when is A minimum? A minimum is 0. Acceleration is 0. When sine is 0. Sine 0 means omega t is 0. Where is it happening? Mean position. So here acceleration is 0. All right, because this is theta. Understand? Here you can understand. Okay, now what is A sine omega t? Acceleration is equal to minus of omega square. What is A sine omega t? A sine omega t was our displacement equation. So you can write omega square is A is equal to minus omega square y. So what does this tell you? This tells you that acceleration is proportional to y, and this negative sign shows that acceleration is opposite direction to displacement. So both the conditions for simple harmonic motion are satisfied by showing this, right? Acceleration is equal to minus omega square y. What this was the first condition. It was acceleration should be proportional to x or y displacement. Second condition was this. Acceleration should be opposite to displacement. Not only acceleration, since acceleration is equal to force by mass. So force is all acceleration time graph from where? From this one. Okay. This is actually what? The gradient change. How gradient of velocity time graph changes. That is how you draw any acceleration time graph. All right. So this is acceleration against time. Okay, let me draw the velocity time graph here. This is VT graph. How was our VT graph? Our VT graph was a cos graph. So this is the velocity time graph. Now you project it over here, the gradient. So where is the gradient bigger? Here or here? 0 or 90 degree, pi by 2. There is a gradient bigger. What can you say about the gradient here? Is it 0? Ashar, what is the gradient here? Mashar, Sanjita, what is the gradient here? How do you find out? What is gradient? Slope. Horizontal line has gradient 0. Vertical line has gradient maximum. Yes? So here what do you have? Here, so how do you draw the gradient? You draw a tangent. Tangent. Every point you draw a tangent. And you look at that tangent. So this is horizontal, right? Therefore, gradient is 0. Then gradient or slope is negative, right? Slope is actually, okay. The gradient is decreasing. The gradient is, sorry, the gradient is increasing. All right. And remember, this is a negative gradient. This will give you a negative gradient. What do you mean by negative gradient? When you calculate the gradient between these two, you will get a negative value. How do you know? The graph is decreasing. The graph is going down means you will get a negative gradient. So it must be in the negative part. So here it must increase in the negative part. Maximum. So how much is this one? This value will be minus omega square y. This is the maximum value, minus value. Gradient is maximum, value is maximum, gradient decreases to 0. So the gradient decreases to 0. Then gradient. Now this part and this part has positive gradient. Why? Because it's rising. If it is rising, it has positive gradient. Therefore, you will have over here. Okay, gradient increases to maximum. So it is maximum. Now the gradient decreases to 0. Decreases to 0. What graph is this? Is it a sine graph? What graph is this? This is a sine graph. It is a sine graph, but it is a negative sine graph. Right? This is a positive sine graph. The opposite is a negative sine graph. Is that shown in our equation? Yes. See, look here. You got a negative sign. You got a negative. Where did you write? Negative. See, look here. Negative sine graph. This is a sine graph. Acceleration is a negative sine graph. That is how, why you got this one. So acceleration is equal to yes. I'm trying to fix this. Okay, acceleration is equal to negative of omega square y. Okay, so this is the constant. This is, so it's a negative y-axis. Y is a positive sine function, acceleration negative sine function. That is why you got the graph like this. You got how you understood how you draw these graphs. Please practice, okay? Please practice. These graphs are just unit 1 revision. Probably a differentiation one you did not do earlier, but the graphs are this one. What is given in your textbook? Oscillations. Yes, you can see this is actually what you got in your textbook. They started with a cosine function. Okay, these graphs. See, look here. So this is the graph given in your textbook. Is it same as what we did, or is there any difference? Tell me.